Hello, friends. There's a little investigation I like to do when we're starting electrostatics, rubbing fur with foam tubes and plastic and that sort of thing. We see attraction and repulsion, and then we think, oh, well, maybe it's like magnetism, right? So then we go ahead and test. Is this a magnet, right? When we create electrostatic objects and their electrostatic interactions, is that just magnetism? So here's a little experiment I use with a magnet and a foam tube rubbed with fur to test. Is electricity or is electrostatics just the same thing as magnetism? When you're doing this, right, you rub the foam tube, when you hold it up, one of the things that can happen, I forgot to warn you about this, is that if you touch this, it's like nothing's really happening anyway, but if you touch it with the foam tube, think about what's happening. The foam tube has a lot of these little extra negatives, and then what's going to happen, it can end up with a static shock, and then this thing is now charged. We want to see just like the magnet, how the magnet uh, is affected by being near this. So let's see what happens. Again, we saw before that a magnet will attract one side and repel the other. So you've got to get this still. If it's not still, it's not going to work. So it's attracting that side, right? And it's also attracting the other side. And then it touches. So since this thing is attracting both sides, is this a magnet? Is this magnetism? No, right? How do we know? Because it attracts both sides of the magnet. If it were a magnet, it would attract one side and repel the other. But it doesn't do that, right? It attracts both sides, which means that this is not a magnet. Okay, static electricity is not the same thing as magnetism. We haven't made a little magnet by doing this. And so the conclusion is, because that rubbed foam tube, electrostatically charged, attracted both sides of the magnet, not one and then attract one side and repel the other, it's not the same thing as a magnet. So getting into a deeper explanation for why that's happening comes a little bit later, the idea of polarization, moving charges, a conductor, etc. But thanks for watching. Don't forget to like and subscribe.